So, my name is Lindsay Jerome, and my partner is John Jeter. And we did our project on emissions versus economy, looking at different countries' GDPs and their climate impact. So, the reason we wanted to do this was because we were kind of thinking about how climate change will have an impact on our futures. We are the generation that will be impacted by climate change. And we hope to see whether there was a correlation between a country's GDP and climate impact. We were wondering if there was something a bit more to it than just big countries make big problems for the earth, or whether it was simply just population size versus global economic impact, and whether that also played a role. We also wanted to see the trends over the years. So, in terms of our data collection process, we definitely hit some roadblocks just finding data. It was a bit hard to find data that fit the requirement sizes, but it also told us that this was something that was not commonly looked at. So, we were excited to dive into something unique. We searched for GDP data for each country and quickly realized that we could definitely find information on their climate impact. And we rounded off the three data sets by looking at country population data. We found these on various databases online with the help of a TA who led us to one with great data.
So our first data set was a CSV file set that had information on each country's climate impact, total CO2 per capita, and we used the data, the total per capita to find the population size. And it had information on going back to like the 1800s. So we cleaned that to where we got the last 20 years of data, so we didn't have too big of a sample size. And we also felt that that would be more relevant to right now. And so when we were cleaning the CSV file, the original file had too many years. There's a lot of blank spaces that went back to that time, which is another reason we got rid of them. And then we also removed the unnecessary data codes because that wasn't really relevant to what we needed to do, as well as getting rid of a lot of other floating information that we wouldn't need. With a JSON file, it was structured differently. It was kind of structured into a dictionary of dictionaries of lists of dictionaries. So we had to go through and kind of clean that up as much as possible, especially because like one of the dictionaries was just a country code, was just a link to the country code, which we didn't need. And just, yeah, kind of irrelevant. And then some countries didn't have certain, what's it called? Like tags, or I guess dictionary finders. It like they all had different ones, or not all had different ones, but some had more than others. So we had to remove those from the dictionary that we didn't want and the data when we cleaned it.
So, in terms of cleaning the HTML file, the HTML file that was online was actually not recognizing the code properly. Shout out to Emily Wu, who saved me by helping me download the HTML into a Sublime file. But once I did that, it worked. So basically, we wanted one specific table from that website that contained information about GDP growth per capita for each country, and we narrowed it down to 1 year for each. And then we used the data from the world and created a new column within the table that contained the comparison between the countries and the world.
So for our first insight, we wanted to look at the size of every country's economy, as well as the CO2 or CO2 produced per GDP, because we wanted to look at the efficiency of a clean economy, not just how much is the total output of CO2, to see who's truly like being more clean. And so the way we did that was we went through the JSON file and totaled up all of the CO2 throughout the years for each country, and totaled up all of the GDP through each country, and then set them not equal to each other, but we set them on a graph, which we'll see in the next visual, or in the visual one. Yeah, and as we see here, United States and China have by far the biggest economies, but they're not the most climate and efficient. As you can see, North Korea and Tobago are way worse in terms of what they are doing per GDP. So it's very interesting to see. But there's still a lot more room for improvement in the United States and China. As you can see that it looks like well over 50% of countries are still more climate efficient than they are. Insight 2.1. So this insight has two parts. It's basically the same code, but it tests for different things. So for the first part, it's CO2 per GDP from 2001 to 2018. So we did 2018 minus 2001 for each CO2 per GDP, and that's just to see if countries' economies are getting more climate efficient. So if they're lowering how much CO2 they're releasing per GDP over time, or if it's continuing to go up, because a lot of countries are pledging, or a lot of European, or America, China are starting to try to become more climate efficient, and we're checking to see if they really are. And so this is a visual. As you can see, a lot of countries have actually lowered their CO2 per GDP, which is a right step in the right direction. But with increasing GDPs, CO2 is still increasing. And we'll see that in the next insight. So this is similar code to the last one. The only difference is it's CO2 instead of CO2 per GDP. And as you can see in this data, a lot of it is actually still rising because we are producing more overall. So even though we're getting more efficient, we're still polluting at a higher rate than we were 20 years ago. If you look at this, there are certain countries. I know it's kind of hard to tell with those names because there's so many, but China is the big one, second to the right, which has pretty much erased any sort of getting cleaner from the countries going down. So CO2 is still being released at a high rate. And then this one is we check the CO2 total throughout each year. So we can see down here on the bottom output graphic that it has continued to go up from 2001 all the way until 2019 before it finally went on the decline in 2020, which is hopefully a good sign and trend of what's to come. And then in the top output graphic, we have total per country. So you can see which country has released the most CO2 over the last 20 years, which will hopefully be able to help us identify problem areas that we can use to help and make their economies more green, as well as look at trends in each year to see what we're doing right and what went wrong in those respective years.
So our insight number 4, we created a pandas data frame combining our HTML and our CSV. And what we did was we basically took all of the data from the HTML file and got it down to the GDP, the percent GDP growth compared to the world growth, and merged that data frame with the one from our CSV file, where we could see the percent change in the average population size, and then compare that to the world as well. And when we merged those two things, we multiplied them together so we could see kind of how each country staggered up in terms of population size and GDP growth compared to the world. And one thing that I found very interesting in this insight was that the two largest populations, India and China, are at exact opposite ends of the spectrum. This graphic on the right is in descending or ascending order in terms of the GDP compared to the world and population growth compared to the world. And so that to me signals that there's something more into the climate change than just necessarily the population growth. And for insight number 5, we did a GUI that provided these different insights. So I'll show you in 1 second what the GUI looks like, but basically the result of the GUI is a line graph of the change in CO2 per GDP in each year with available data for each country. So this can help us predict future trends or look at different regions throughout the world to see what might be causing differences. So I'm just going to switch over to the GUI really fast. And so we get the screen pop up. We'll go with Afghanistan. And you can see the graph there. And if we want to close that out, we can select all of the countries from the world, hit get graph, and it will show us all of the different graphs for each country. So in conclusion, we learned that there is definitely more to climate impact than just the size of the country and the population size. We saw that there was not a strong correlation between GDP and CO2 output, but there was still a positive one, even though it was just weak. I think our next steps, we would be interested to look at the leading industries of each country and see whether industries such as manufacturing, whether or not they have a smaller or larger population, still have a larger climate impact than larger countries that might be more focused on tourism.